Welcome to Math 300. I know that there is a good amount of resources available through my math lab, but I wanted to create videos that were narrated by me and showing you some of the ways I would explain things that are in this book in order to supplement that instruction. And so we're starting our investigation in our class. Our class is really topics based, and so for the next little bit, over the next two chapters, we're going to look at some ideas from statistics because we really see those applied a lot in our lives. And so one of the good critical thinking aspects that's brought up here in chapter 11 is probability. And so it's not a huge concept. You won't in terms of a heavy math concept, you won't be using a lot of algebra, but you will be using a lot of mathematical thinking or critical thinking as you go through here. And so, as noted in the narrative to this section, as you find it in the modules, there's a few things that are being taught here in relation to probability. And so, I want to go over some of those with you. I want to just start with a simple example of rolling one die. One single six-sided die. And let me just make sure that I call it a six-sided die. So as we roll that die, you know what can come up. One can come up, two could come up, three could come up, four could come up, five, or six could all come up. That's six different outcomes. These outcomes are known as the sample space. The sample space is a list of every single possible outcome. And if we're going to be asked for a certain probability, then we'll be able to answer that. So let's suppose we are asked this question. Find the probability that the outcome is, and let me just put A. Find the probability that the outcome is 2. Well, the way that we find probability is the number of ways the event can happen over, I'm going to word it like this since we've defined sample space, over the size of the sample space. Right? Sometimes it's written as the number of ways an event can happen over the total number of possible outcomes. This is the traditional or classical way to define probability, and it works really well. So for us, when we want to find the probability of something like 2, and maybe notation wise I should change what I have up here, not just put a P, but put a P of a number of ways the event A can happen over the size of that. So if I want to know the probability of 2, I just have to look back up here at my sample space. How many 2's are present? How many ways can 2 come up? One way out of 6 total answers coming through. So that is how we find probability. It's pretty simple. So they're going to ask you to list out the sample spaces and then determine probability in much of the homework, right? That's what a majority of the homework looks like. So let's go to something like rolling 2 dice and go forward and do the same thing. Again, it's six-sided. Well, here I got to be a little bit careful. I could get the sample space. If I go there, let me just write sample space. Let's determine the sample space first. And this may be a duplication of a homework question. May not be. They do have it in the book homework. I just don't know if it made in the online homework. The sample space for this setting is this. 1 on the first die, 1 on the second die. 1 on the first die, 2 on the second die. 1 on the first die, 3, 1, 4, 1, 5, 1, 6. So it may be advantageous for me to make these second ones in red. Let me just go over these guys and put them in red. Because what I want you to picture is a blue die and a red die. Because it does make a difference who's number 1 and number 2. So it could be 1, 1, 1, 2, 1, 3, or it could be 2 or 3, or I could put dot, 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 5. Well, let me go all the way out to 6. 6. And it could be 2, and all the way down to 2. So this is just trying to represent 2 on the first die, 3 on the first die, 4, 5, 6 on the first die. And that second die, which is in red, could come up to be 1, 2, or 6, 1, 2, or 6, or anything in between. 1, 2, or 6. So that would be the sample space. With all that stuff filled in, I'm just trying to save some time. So notice that 1, 2, let me highlight that in yellow, that 1, 2 is different than 2, 1. Those are two different ways to get the outcome of a 3. So rolling 2 dice, we would have that. So we could ask some questions now. First of all, the size of the sample space, I think you can see it is 36. We have a 6 by 6 grid. So let me ask some more questions here. Go back to a blue pen maybe. And let's ask a question. What's the probability that we roll a 7? Well, I got to think about the number of ways there are to roll a 7, and what we mean by 7, and let me be careful of that, a total of 7. Well, there's 36 ways for that die to produce an outcome. How many of those produce a 7? Well, there's a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6 and a 1. So there's 6 out of 36 ways, and our book will always reduce, so we have 1/6 of the probability is 1/6. And so you have these nice probability questions that are there. Even in simple settings like this one here where we have the probability outcome is 2, I noticed that I put an A there. Probably should have continued. Let me come back up here and ask a different question. Get rid of some of these. So we saw the probability of 2 was 1/6. And we can ask other questions like the probability that the outcome is odd. Well, this we saw the probability of 2 was 1 outcome out of 6. The probability that it's odd, well, let's go count the odd ones. 1, 3, 5 are all odd. That was 3 numbers that I mentioned out of 6. Or the probability, not surprisingly, is 1/2. Half those numbers are odd. And so probabilities really help us to figure out the chances, but it's as easy as stacking 2 numbers and reducing them. And so we could see the probability of rolling a 7. It would be a little bit difficult of rolling an odd. There's a lot to count in that, but they could ask those types of questions. So you're going to establish that sample space and then write what you have. The other concept that they have in here is odds. You hear odds a lot when you hear about like betting and things like that. It usually is associated with gambling. But there's other odds, like odds that somebody's going to live over the next year. So there's 2 types of odds. There's odds against, which is used most frequently, and there's also odds in favor. So odds against is simply, I'm going to try to state it in the most simple form. And it may be different than the book, but I like that because it may be giving you a different approach. Odds against is, remember the word against. Whoops, I spelled that wrong. I forgot the N. So remember the word against. So it is the number of ways it can't happen over number of ways it can. And odds in favor is the flip of that. It's the number of ways it can happen over the number of ways it can't. So let's give you an example of that. Let's stick with this 2 dice example. 2 6-sided dice are thrown. And we want to find the odds against rolling a total of, let's pick another number, of 5. No problem. What we need to do is remember what our sample space looks like. It looked like 1, 1, 1, 2, all the way down to 1, 6. 2, 1, 2, 2, all the way down to 2, 6, so forth and so on to 6, 1, 6, 2, all the way down to 6, 6. So notice that odds doesn't ever take the total sample space or the size of the sample space. It literally is counting the number of ways it can over the number of ways it can't, or vice versa. So let's take a look at 5. What are the ways there are to roll a 5? Let me start with 1. 1 and 4 will do it. 2 and 3 will do it. 3 and 2 will do it. 4 and 1 bring me there. And I can't go up to 5 because there is no 0. So there's 4 ways to get 5, to get a total of 5. So 4 is the number of ways it can happen. If you remember, there were 36 total possible outcomes. So that means that there's 32 ways it can't happen. So if I want odds against rolling a 5, it's against is negative, so we are going to, in terms of a negative connotation, so we're going to put the negative thing, it not happening, over it happening. Okay, and if it was odds in favor, all it would be is reversed, can over can't. The two together initially should add up to be the total sample space, and then what we do is we reduce. And you can see 4s are brought out of that, so that's 8 to 1, and this is 1 to 8. Now these are ratios, not numbers, so you want to leave this as a fraction. I'll put leave in fraction form. We want to know that it's 8 to 1. Okay, or it's 1 to 8 if it's odds in favor. So that's what you're going to have towards the end of this section, is some odds types of questions. Figure it out pretty much the same way. You understand that sample space first, and then you stack some numbers and reduce as you need. So as you go and do the skills review for chapter 11, that's the Math 95 portion of the course. That is going to allow you to probably play around with the reducing fractions again. Make sure you understand that material. So this is what 11.1 is all about. Any questions or concerns, see me in the Zoom or shoot me an email and we'll get you a good response as quickly as possible.